Hi guys, it's Talha here again today. Today, what we learned at our in our programming class was about we learned we did two programs which were related to user-defined functions, and yeah, the first program the first program which we did was about when we were supposed to when we were for example, we were supposed to prompt a set of values, for example a set of values from from 1 to 10, or a set of 10 values, and then we were supposed to output the largest and then we were supposed to output the largest value out of these 10 values, and we were supposed to show it on the screen. And then the using the larger function which we created, the user defined function that was named larger, which we created in the previous class. And this function showed the larger of the two values, and then an output, and then it gave you an output of the larger value. And this was the parameters of the function. And the second one which we did in the class was, it told us to make a user defined, or to make a custom function, or to make a program which prompts the user to enter, for example, S for the area of square, and then input R for the area of rectangle, and then input T for area of a triangle, and then it should what it should do, it based on what the user entered, it will output the area of that specific figure. And then using the if else or switch case statement, and you were supposed to make a function that was named area, and using some parameters in it, and you were supposed to make one function in which all of these three functions, all of the formulas for calculating the areas of these three figures were included. So you were supposed to make a one function for all of these three figures' areas. So let's first discuss our first problem. Our first problem was that we were supposed to get an input from the user of 10 10 random numbers, and then we were supposed to show the larger of these 10 numbers. So first what we did, so first you know first we were supposed to create a user defined function which outputs the which gives you an output of the larger value. So what we did, we made a function. No, first we defined the type, what type of value this function is going to return. So that will be double, of course. So then we input larger is the name, this is the type it will return, this is the name of the function. Then the parameter list, and in the parameter list you are also supposed to mention the type of the parameters. So for example, I say double x, and spaces in between, then a comma, and then I input double y. So this is the function. Now in this function I am supposed to create a body of this function inside, the code which is required by this function to execute the actual parameters you're going to use when you're going to call this function. So what I'm going to do, I'm going to create the body, I'm going to write the specific code for this function. So what I'm going to do, I'm going to this function is supposed to give you a larger value. So the logic for for uh, the function which gives you a larger value is, if I say if x, the first variable, the first formal parameter, if first formal parameter, or if x is greater than or equal to y. So remember, we cannot, for example, if you want to say that you want to, if x is greater than y, you want to return x. If x is smaller than y, you want to return y. And then else, if x is equal to y, you want to return that the values are equal. But there's a there's a specific logic behind it, and you cannot do that because this the return type of this function is double, not a string. So when you are going to return, for example, not equal, so you're going to write that in a string, but that is not going to be returned because the return type is double. So you've got to be careful not to return any value except the double value of the function. So you have, if x is greater than or equal to y, you return x, or else you return y. So this is the function, or this is the user defined function you are going to use inside your main program, which was, you were supposed to get an input of 10 numbers, and then you were going to show which one is the largest one. So for what you do, you write int main, sorry, there's a space, so you write int main, and okay, so first what you do, you declare the the prototype of the function. So what is a prototype? Prototype is just the heading of the function without its body. So you have double, so this is the prototype. You have double, on the top you have already written hash include and that stuff, hash include conio.h, hash include iostream, all that is already written. I'm not going to write that again. I'm just going to write from the prototype thing. So you have double, you have larger, and then for the prototype you have double, it's an exception whether you want to write the formal parameters in the prototype section or not, but I'm going to do that. So you have double x, you have double y. So this is going to be your prototype. So when the compiler is going to compile this, when it will come to this, it's actually going to know that this function actually exists somewhere in the program. So it will pre-calculate it, and when you call the function, it will know that you call this specific function, and then it will jump down to the body of the function, execute it, and return the value back to the place where you called the function. So you just declared the declared the prototype of the function. Next what you do, you'll create the function main. It's compulsory because when a compiler compiles the program, the first statement in the main function is always executed first. So you have main, and you can also leave the parameter list empty, and when you call the function, you've also got to mention the empty parameter list. So it's not necessary that you'll have to have actual or formal parameters inside the parameter list. You can also leave it empty. So you have int main, and you declare the variables. You declare the variables here, all the variables, that is int I, and you have double, you have num, and you have max. So you declare two variables here, two variables of the type double, and one variable that is I, and that is going to be the int. No, or you don't have to declare I, sorry, you can just declare double, num, and max. So here I'm going to see out, or prompt the user to input 10 numbers, and then I'm going to see in num, and I'm going to store this value in the variable max. So up till now the compiler only read the first number, and we are assuming that this number is the largest number of the 10 numbers the user is going to input, because we don't know what the user is going to input, so we assume that the first number user entered is going to be the largest one. So what we do after that, we create a loop. So alright, so you also need so you have while. So you have while, because the user is going to input 10 numbers, because the user is going to input only 10 numbers. So what you're going to do, you're going to say while I is less than or equal to 9, because you've already entered first number, and now you want it to be compared with the later 9 numbers. So what you're going to do, while I is less than or equal to 9, you input num again, then what you do, you store the value of the function larger, and the actual parameters of this function are going to be max and num, and then you say I plus plus, and then you end the loop. So what it's going to do, it's first, I is 0, we initialize I at 0, so I is 0. So what it's going to do, first is going to see in num, and it's going to store the num's value in max. Then what it's going to do is going to come down to the loop. It's going to ask you again for an input num. So, and then it's going to store is going to compare through the function we had just defined a few seconds ago. So through this function is going to compare which one is larger, and then it's going to store that value into max, and then it's going to increment the counter again. When I equals 1, it's going to again do the same, as going to compare every larger value with the forward value or with the later value, and at the end it's going to give you max, and you're going to see out max, which is going to be your largest value. So you see out max, which is your largest value, and then you put return 0. So this was your program. And the second one which we had to do was to find the areas of different figures, and we had to make a user defined function which outputs you, or which includes the formulas for the areas of every, or for all of the 3 figures. So that was our challenge. Actually, I don't have that much time, so what I'm going to do is I'll leave that program to you guys, because teacher hasn't explained it, but he will later on. But and teacher also gave us an assignment for the program exercise. That was question 1, 2, 3, and 4. So we are also supposed to do these questions as well. So alright, let's now jump on to our calculus. What we learned about calculus today. So what we learned about calculus was about right hand limits and left hand limits. So what it basically means is, for example, we have a graph. And here this is an open interval, and right here this is an open interval, and this is 0, this is 1, this is -1. So when x is approaching 0 from the left side, from the right side, when x is approaching 0 from the right side, its limit is 1. So how we are going to write it mathematically? We are going to write it mathematically as when limit of x approaches 0 from the right side, means from the positive side, means x is greater than 0. X is greater than 0. We insert a positive sign here. So what is f of x? Its limit is 1. But when we approach x, x equals when we approach x equals 0 from the left side, from the left side, so then x is smaller than 0, because 0 is positive and x is going to be negative, because we are approaching it from the left side. So when x is smaller than 0, limit of x approaches 0 minus, because it's approaching from the left side, f of x equals -1. So basically this is a discontinuous function, it's not continuous. And this is a discontinuous limit, it's not a continuous limit. And also its limit does not exist, because from the left side it's approaching one value, and from the right side it's approaching another value. So we cannot estimate what value this function is going to approach, because from one side, from the positive side is approaching 1, and from the negative side it's approaching -1, so we cannot assume what exactly its limit is going to be. So that is why its limit does not exist. So that was about right hand and left hand limits. Also we discussed the limit when x approaches infinity, or when x approaches minus infinity. So for example, you have a function that is f of x. For example, you have a function that is f of x equals x by x absolute, or you can say 1 by x absolute. So if I say that limit of f of x when x approaches plus or minus infinity, because minus infinity will obviously become positive because it's an absolute sign. So what's going to happen? That is going to be, what is that going to be? That is going to be 0, because when 1 is divided by infinity or minus infinity, it becomes when x becomes really large, this inverse value, or the reciprocal value, is going to be really small, and that is going to approach 0. So what we say, that limit of f of x when x approaches positive infinity or negative infinity, its answer, or its value, it's going to approach 0 when x is greater than, or when x approaches positive infinity or negative infinity. Now let's say you have a rational function. Where, for example, we say that 2x square plus 2x square plus 3x divided by 4x square plus 2x. So if you have a function like this and x is approaching infinity, and you have to find the limit of x when x approaches infinity. So you have limit of f of x when x approaches infinity. So how are you going to rationalize it? There's a way you can rationalize it and you can solve this problem. So what you do, you multiply, or you take common the highest power of x from the denominator. So you have the highest power of x in the denominator is x squared. So what do? You take x squared common, and you say x squared into 2 plus 3 by x, and down here x squared into 4 plus 4 plus 2 by x. Yep, 2 by x. So it's going to be like this. So what will happen? The x square and x square will cancel out. You have 2 plus, and remember, as I said, any number divided by infinity, so first you're going to apply the limit. When you apply the limit, 3 by infinity, 2 by infinity, it will become 0. So you have 2 plus 0 divided by 4 plus 0. It's actually going to give you 2 by 4. It's actually going to give you 1 by 2. So its limit, or the number it's approaching, is 1 by 2. Now there's another problem where you have in this types of function, that is a rational function, you have to rationalize the function by taking common the highest power of x from the denominator. But what if the power of the denominator is larger? For example, this is 2x squared plus 4x divided by 3x cubed plus 2x squared. So what if it's like this? The power, or the highest power of the denominator, is larger than the numerator. So in this case, it's actually going to give you 0, because when you take x cubed common, it's actually going to give you 2 by x plus 4 by x squared, and you divide it by x cubed common, take 3 plus 2 by x cubed cancel out. You have 2 by x 0 plus 4 by x squared 0, because you're applying limit, that is x approaching minus infinity or plus infinity, and you have divided by 3 plus 0, so it becomes 0 by 3, and anything where the numerator is 0 and there no matter what the denominator is, it's actually going to give you 0. So guys, that was about right hand and left hand limit, and about when x approaches infinity, what is going to be the limit. And I hope my lecture helped you guys somewhat. Thank you so much.